Alright, so we're in MATLAB now, and we want to use MATLAB in order to implement this very simple artificial life algorithm known as Langton's ant, and then we want to, see how it actually plays out. And I'll give you a hint. It's if you've never seen it before, something very unexpected happens when this thing plays. So this is the template that you're going to use. Since the focus of the module this week is on graphics and animation, I am basically giving you the algorithm that's needed to implement Langton's ant, and that way you can just focus on the graphics and animation. So what you can see is we first of all set a grid. In this case I set it to 100 by 100. Set it to all zeros. All zeros indicate the grid squares are white. I specify the bounds of the grid so that if the ant tries to move off the grid, we halt the animation. Place the ant in the middle of the grid, 50-50. The directions are 0 degrees is pointing east, 90 is north, 180 is west, 270 is south. So the ant is initially facing east. Okay, there's a graphics part that you're going to have to do as part of your homework. Then we specify the axes so that we get the full 100 by 100 grid. Set a variable in order to determine or to keep track of whether the ant is still inside the grid, because once it's outside then we'll just stop. Also keep track of the total number of steps. You'll see why later that's an interesting thing to note. Then what happens? Well, if the grid color is 0, that means the square is white. If that's the case, then the ant needs to turn 90 degrees to the right. Else, otherwise, the square is black. That's the only two choices, and thus the ant direction changes by minus 90 degrees, so you're turning 90 degrees to the left. Okay, well that's great, but of course then one way or another you're going to end up with either less than 0 or greater than 360. So what this does is just modify the direction so that it stays within the range of 0 to 360. Alright, then the ant always flips the color of the square that it's on, so grid color is the inverse or not of the grid. Because it's 0, it turns it to 1. If it's 1, it turns it to 0. Alright, that's fine. So if the grid color is 0, then you need to do the graphics to make that marker white. Otherwise, the grid square is black, and so you'll need to fill in the graphics command in order to make the marker black. There's one other command that is needed in order to execute what you've set with these two graphics commands. And then the rest of it's given for you. So the ant motion, the direction of motion, is given by the cosine and sine of the direction. You'll see I'm using an alternate form here, cos d. That means the cosine where the argument is in degrees, and this is the sine where the argument is in degrees. Then that results in values of either 0, +1, or -1 in both cases. And so then you move the ant by taking the previous position and then just adding on 1, 0, or -1. And then finally, we look to see whether or not the ant has moved off the grid, and if that's the case, then you set inside to 0, which terminates the while loop, and you are done.